8.51, we have a reaction between MnO2 and HCl. It's already balanced for us. On the exam, you'll have to balance your own reactions. So make sure you can do that. There will be a few opportunities for you to do that on the exam and earn those points. So again, to balance it, you make sure you have equal numbers of each element on both sides of the arrow. So this question says you have 0.86 moles of MnO2. And it says you have 48.2 grams of HCl. Which reactant will be used up first? How many grams of CO2 will be produced? So really the way the question is worded isn't totally good, because the question is, when it says how many grams will be produced, that's really asking, if you did this reaction, how many grams of product would you get? But we know in real life, we don't always get as much product as we possibly could. So really what the question should be asking is, what they really are looking for is, what is the theoretical yield of CO2 in grams? Theoretically, how much CO2 could we get if the reaction went to completion? We know that won't necessarily happen, so we have to be aware that what we'll actually get is not something we can know until we actually do the experiment. But we can predict, or at least calculate, what the maximum amount of CO2 possible could be from the limiting amounts of the reactants that we put in. So the way that we talked about doing that last time was to do two calculations, one for each reactant, to figure out, starting from just the MnO2, if that were completely used up, how much product would I get? And then a separate calculation to calculate, if all the HCl I have were completely used up, how much CO2 would I get? We have those two calculations. Whichever one gives us a smaller amount of CO2, that will be the theoretical yield. That will be the maximum amount I can make. Because at that point, I've discovered which is my limiting reactant, which one is limiting how much CO2 I can make, based on how much reactant I'm putting in. So I want to do two calculations. How many grams of CO2 would I get from 0.86 moles of MnO2? And how many grams of CO2 would I get if I have excess MnO2 and the HCl is limiting? I need to calculate that, because if I only have 48.2 grams of HCl and I run out of that one first, I won't be able to make as much CO2 as the other calculation would predict. That's why I need two calculations to see which one is really limiting how much CO2 I can make. So to do the calculations, I will recognize that in any calculation where I'm starting with a quantity of one substance and I want to convert that into a different substance with a different identity, I need to convert to moles first, because the only relationship I have between the quantities of different substances is a mole relationship that comes from the balanced reaction. So in this top calculation, I've already got moles. I need to then cancel moles of this substance, MnO2, and get moles of the other substance I'm interested in. In this case, in the balanced equation, it happens to be 1-to-1. And then if I want to convert moles of Cl2 into grams of Cl2, that relationship, when I'm not converting from one substance to another, just converting from grams to moles or moles to grams, that's the molar mass from the periodic table. So 2 times 35.45 gives me 70.90 grams per mole for the Cl2. So that cancels the moles. I've got the units I want, so I multiply that by the 0.86, and I get 60 point, well, I've limited to 2 sig figs, so I've got to round that 0 up to a 1. So 61 grams of Cl2. So what I just calculated is the amount of Cl2 I could make if I assume that every bit of the MnO2 reacts. But I don't know if it can all react, because if I only have a little bit of HCl, then the HCl, if I run out of that, then I won't be able to make as much Cl2 as I calculated there. So I need my second calculation to figure out how much Cl2 would I get from the amount of HCl I have if it were to completely react. So here, my starting amount is in grams, and if I have information about one substance, I want information about a different substance, I've got to convert to moles first. So I have to cancel the grams of HCl and get to moles of HCl. So within one substance, not going from one substance to another, grams to moles, that's the molar mass. So I add the mass of one hydrogen and one chlorine, and I get 36.46 grams per mole. Now I have moles, so I can convert this into the substance of interest. And in this case, it is a 4-to-1 relationship. So 4 HCl required to make 1 Cl2. So now the top and the bottom are equal. I cancel the undesired units. Now I've got moles, and so I just need the same step I used in this last step of the previous calculation. To cancel moles and get grams. So this one just multiply 48.2 divided by 36.46 divided by 4 times 70.9. And I made a mistake, so I got to do it again. 48.2 divided by 36.46 divided by 4 times 70.90, and I get 23.4. And here I do have enough information to get 3 sig figs. Just to point out, this relationship between moles has infinite sig figs. It's an exact relationship, right? There's no uncertainty about these coefficients here. Once the reaction is balanced, I know it's exactly 4-to-1. It's not something close to 4, like 4.02. There's no uncertainty there. I don't need significant figures to express how much certainty I have in these whole number coefficients, because the whole number coefficients are exact, because I can't have a fraction of an atom. I have an exact number of atoms to keep that reaction balanced. So that will not limit my sig figs in my answer. This 3 sig figs is going to limit. It's the one with the fewest, so I have 23.4 grams of Cl2. So the question was asking, which reactant will be used up first? What's the answer to that? The HCl. Right? So don't just look at the numbers and say, well, I've got a higher number in front of my HCl, so that must mean I have more and I won't run out of it as quick. You've got to do the calculation, because even if these two numbers had the same units, they're still not comparable, because they represent different substances, and in the reaction, the mole ratio for those substances can sometimes make it misleading if you just look at which substance you have more of to begin with. So the limiting reactant isn't necessarily the one you have less of, it's the one that limits how much product you can make more. And so that's why I do this calculation. I figure out how much product I could make if all of the one reactant were to be used up. How much product could I make if the other reactant were to be used up? The one that's smaller, that one tells me that that substance is the limiting substance. That's the one I'm going to run out of first, because when I make 23.4 grams of Cl2, I don't have any HCl left. I still have enough MnO2 to make 61 grams of Cl2, but I can never make it because I've run out of HCl at the point when I've made 23.4 grams of Cl2. So this is the limiting. HCl is what I will run out of first. And in the second part of the question, how much Cl2 maximum could I make? That's here. This is my theoretical yield. That's the maximum amount I could make, 23.4 grams, because that's once I hit that amount, I run out of HCl. I can't make any more.